In today's video, we'll be talking about electric charges. After watching this video, you should be able to understand the charge on a proton, neutron, and electron, and be able to determine the amount of a charge on an object and know the unit of charge. Okay, so kind of like how mass has a unit of grams, what is a unit of charge? Okay, let's get right to it. Just some basic chemistry for you guys. Matter is made up of atoms, okay? And at one point in time, the atom was thought to be the smallest particle that you could find on Earth, okay? So nothing could be smaller than the atom. We now know that you can break an atom into even smaller pieces, and in the atom there is something called a proton, which has an overall positive charge, an electron, which has an overall negative charge, and the neutron, which is neutral. Okay, so those are the parts of an atom. And just a little chart, if you will, for you guys, if you're interested. The proton and the neutron are both found in the nucleus, okay, in the nucleus. Whereas the electron is found outside the nucleus, orbiting around that central point. The proton and the neutron are very tightly bound. It is very difficult to separate them. Whereas the electrons, they're relatively weakly bound, meaning that they are easily able to be taken away. The proton, like I said, has an overall positive charge. The neutron has no charge, and the electron has an overall negative charge. And in terms of size, the proton and the neutron are much, much, much larger than the electron. The electron's a tiny little fellow compared to, say, a proton or a neutron. So in electrostatics, which is what we're talking about now, we actually don't care too much about protons, and we actually don't care too much about neutrons. Neither of those are that important in electrostatics. It's all about the electrons, and so hence the name electricity. Electricity is electrons, okay? And so we're dealing with protons, absolutely, but the electrons are really what we're interested in. So the electrons are found in the electron cloud, which surrounds an atom, or the nucleus of an atom. Electrons, they do not like each other very much. Okay? So they do not want to be close to one another. They don't. It's like a person that you just despise, right? You don't want to even be in the same room with them. Electrons are kind of the same way. They want to be as far away from one another as possible. So what's really crazy to think about is actually when you bring your hand near an object, the electrons in your hand, because your hand is made up of atoms, and the electrons in whatever it is you're trying to touch is also made of atoms, they actually repel each other. And so you actually feel the repulsion of these electrons as pressure against your skin, which we call touch. Yet you never actually touch the object, which I think is really freaky. So you actually aren't actually really touching anything because of this electrostatic charge that's basically repelling each other, because electrons do not want to be right on top of one another. So what is the difference between being charged and being what's called neutral? All right. The number of electrons that surround the nucleus compared to the number of protons will determine if an atom is electrically charged or electrically neutral. Okay? If an atom has an equal number of protons and electrons, the atom would be described as neutral because it has equal number of positive and negatively charged particles. Okay? So they can cancel each other out, and we call that neutral. If an atom has an unequal number of protons or electrons, then the atom is now charged, and it's no longer called an atom. Instead, we refer to it as an ion. Okay, so ions are charged particles. Either they have more protons or more electrons. So you don't have that equal balance anymore. Okay, and so that's the difference between being charged and being neutral. So how strong is the force supplied by electrons? So charge is represented typically by a little q, okay, which is right there. Right? So in equations and stuff, if you see a q, that's referring to the charge. Okay? And the units of charge is something called the coulomb, and that's represented by a big C, okay, coulomb, big C. And a coulomb, I kind of like to think of it as like a crate of electrons or a crate of protons. It's basically the charge of a whole bunch of electrons or protons. Because if you notice, 1 coulomb or 1 C is 6.25 times 10 to the 18th E, which is the elementary charge, which is the charge of one proton or one electron. So that's a huge number. This is absolutely huge. Okay, so 1 coulomb is a ton of protons or electrons. Okay, it's a really big number. And then there's something called the elementary charge, which is represented by a little e. Okay, a little e. And the elementary charge is the value of 1 electron or 1 proton, the charge on just 1 electron or 1 proton. And that value is 1 little e equals 1.6 times 10 to the negative 19th coulombs. And this is a really small number, okay? So this is why I kind of think of a coulomb as like a crate of electrons or a crate of protons. It's just a whole bunch of them all piled together, and it's this huge charge. 1 coulomb is a huge charge, whereas a elementary charge is just 1 little proton or 1 electron by itself. What kind of charge would it have? And these numbers, 1 coulomb is actually the inverse of 1 elementary charge. Okay, so if you take this number and you take 1 divided by that number, you would get this down here. Okay. So let's do some example problems on things that I could ask you. An object possessing an excess of 6 times 10 to the 6th electrons, what would the net, or an object has 6 times 10 to the 6th electrons, an excess of those. What is the net charge on the object? Okay, so what is the net charge on the object? Okay, so first thing I want to know is, well, what kind of charge does 1 electron have? 1 electron has a charge of 1.6 times 10 to the negative 19th coulombs. Okay, so that would be the charge that 1 electron would have. 1.6 times 10 to the negative 19th coulombs. Now I don't have just 1 electron here. I have 6 times 10 to the 6th electrons. So what do I do? Well, I'm going to take 6 times 10 to the 6th. And what I'm going to do is I'm going to put this, I'm going to set up a kind of a dimensional analysis type problem. The charge on 1 electron is 1.6 times 10 to the negative 19th. Okay, so I can then just multiply right across. 6 times 10 to the 6th times 1.6 times 10 to the negative 19th. I would get a charge, or a Q, of negative 9.6 times 10 to the negative 13th coulombs. Okay. Now, why is it negative? Well, it's because we are dealing with something called electrons. Electrons are negatively charged, and so you would have a overall negative charge. If it has more electrons than it does protons, you have something that has an overall negative charge. Okay, so negative 9.6 times 10 to the negative 13th coulombs, which again is a really small number, but remember, electrons are a really small thing. Let's do another example problem. An alpha particle consists of 2 protons and 2 neutrons. What is the charge of the alpha particle? Okay, so protons are positive, right? And neutrons have no charge, so we could kind of care less. We really don't deal with neutrons at all. What is the charge of the alpha particle? So if it has 2 protons, I want to know what is the charge of, say, like 1 proton. All right, well, one proton is equal to the elementary charge, which is 1.6 times 10 to the negative 19th coulombs. Okay, but I have 2 protons, right? So what do I do? Well, I'm going to take 2 protons times the charge on just 1 proton, which is this, 1.6 times 10 to the negative 19th coulombs. Okay, and if you do that math, you would find out that you would have a charge of Q equals 3.2 times 10 to the negative 19th coulombs. Oops, sorry. That box went kind of crazy on me. So 3.2 times 10 to the negative 19th coulombs. Let's do one more problem just for fun. If an object has a net negative charge of 4 coulombs, the object possesses what? Okay, big hint here. It says that it has a net negative charge. So it has more what? Protons or electrons? In my head, I'm thinking it must have more electrons because it has an overall net negative charge. So right away, I can cancel out these 2 options down here because it's saying it has more protons, right? And protons would not produce an overall net negative charge. So it's either option 1 or 2. So it has a net negative charge of 4 coulombs, right? My question is, what does 1 coulomb equal in terms of how many electrons is 1 coulomb, I should say. Now 1 coulomb is 6.25 times 10 to the 18th electrons. Okay, so 1 coulomb equals 6.25 times 10 to the 18th electrons. And I have here 4 coulombs, right? So I would have actually 4 coulombs times the charge of 1 coulomb, which is 6.25 times 10 to the 18th. And if you do that math and you multiply that baby out, you would find that you would have 2.5 times 10 to the 19th electrons, or excess electrons. Okay, that's how many excess electrons you'd have. And is there an answer here that would follow that? There is. It would be number 2. Okay, so that takes care of this video. I will see you guys next time.